Hello everyone, I am Mohammed Mahbub. Today I am going to explain class 10, chapter 1, real numbers, exercise 1.4. Let us see the question. Exercise 1.4. First question, show that root 2 is irrational. Show that root 2 is irrational. Okay? To prove root 2 is irrational, we have to follow few steps. What are the steps? The first one, we assume that let us assume that root 2 is a rational. Root 2 is a rational. This is our first step. Remember. The second step, if root 2 is a rational, then root 2 is equal to what, ma? A upon b. And A comma B are what? A comma B are co-primes. What is the definition of co-prime? A and B have no common factor other than 1. A and B have no common factor other than 1. So after this step, cross multiply. Root 2B is equal to what? A. Squaring both sides. Root 2B whole square is equal to a square. We know that if we are taking the squaring both sides, we have to take the power 2 here and here also we have to take power 2. So root 2b square, which means what? Root 2 square and b square. Very good. So what is the root 2 square? Root 2 square means 2 and b square is equal to what, ma? A square. We have a theorem, if p divides a square, p also divides a. So we have to read here 2 divides a square, 2 also divides a, then 2 is a prime. So here 2 divides a square, then 2 also divides a. Okay, so what is a? A is nothing but it is a prime. So we have to write here a is equal to what? Let a is equal to multiple of 2. What is multiple of 2? Suppose here we are in the case 2 divides b, 2b square is equal to a square. 2 divides a square, 2 also divides a. A is a multiple of 2, which means a is equal to 2c. We have to substitute here. What is the equation? 2b square is equal to a square. In place of a, we have to substitute a is equal to 2c. Understood now? In place of a, we have to substitute 2c. And power 2, we have to write power 2. 2b square is equal to 2 square, 4c square. Okay, it will cancel, 2 ones are 2 twos are. So what we have, b square is equal to what? 2c square. Or we can write, if LHS is equal to RHS, then RHS also equal to LHS. We should write 2c square is equal to b square. 2c square is equal to what? B square. How to read? 2 divides b square, 2 also divides b. 2 also divides b. Okay. So we observe that in two cases, 2 is a common factor of 2 is a common factor of a and b. A and b. Because we are observing 2 divides a square and 2 also divides a. We observe that 2 divides b square, 2 also divides b. 2 is a common factor of a and b, where a comma b are what, ma? Co-prime, which is contradiction. Which is contradiction. Which means what? If both are the co-primes, means it doesn't have any common factor other than 1. But here we observe that it have the common factor 2, which is contradiction. Which means what? Root 2 is not a rational. Root 2 is irrational. Please copy this answer. Okay, my second question is, show that my second question is, show that root phi is irrational. Root phi is irrational. Okay. To prove root phi is irrational, again we have to follow few steps. What is the step one? Very good. Let us assume that root phi is a rational. Root phi is a rational. First step. What is the second step? If root phi is a rational means root phi is in the form of a upon b na, where a comma b are co-primes. What is the definition of co-primes? Very good. Two number is said to be co-prime, not have any common factor other than 1. So we have to cross multiply. What do we get? Root phi b is equal to what? A. Then squaring both sides, same method. We will get root phi b whole square is equal to what? A square. Again root phi square. Root phi square is 5b square is equal to what? A square. We have a theorem, p divides a square, p also divides a, where p is a prime. Similarly phi divides a square, phi also divides a, where phi is a prime. We'll write here phi divides a square, then phi also divides a. So what is a? A is nothing but multiple of phi c. We should substitute here phi b square is equal to what? A square. But what is a? Phi c. So phi b square same. Again exponential form, ab square means a square into b square. So phi c square means phi square into c square. Phi square is 25 c square. Phi 1s are 5, phi 5s are 25. So b square is equal to phi c square. If LHS is equal to RHS, then RHS also is equal to LHS. B square is equal to phi c square, then phi c square is equal to b square. How do we read? We read phi divides b square, then phi also divides b. Okay, which means phi is a common factor, which means phi is a common factor of both a and b. Okay, here phi divides a square, phi also divides a. Phi divides b square, phi also divides b. Phi also divides b, which means what? Phi is a common factor of both a and b, which is contradiction. Yes, very good. Which is contradiction. Why? Because a comma b are what, ma? Yes, very good. Co-primes. So root phi is what? Irrational. Root phi is irrational. Hence proof. Please copy this one. Now we have a third question. Show that root 3 is irrational. Okay, we have to follow the same step. The first one, very good. Let us assume that root 3 is a rational. If root 3 is a rational means root 3 is equal to what? A upon B, and A upon B are what? Co-primes. Okay, next step, cross multiply. What do we get? Root 3b is equal to A. Root 3 multiply with B. Root 3b is equal to A. Next step, squaring both sides. So root 3b square is equal to what? A square. So what is the root 3 square? Yes, very good. 3b square is equal to what? A square. How do we read this? The theorem, P divides A square, P also divides A, P is a prime. Similarly, 3 divides A square, 3 also divides, 3 also divides A. 3 also divides A. So what is A? We assume A is equal to 3C. We substitute the value of A in this equation. 3b square is equal to what? A square. What is A value? 3c. So 3c is square. 3b square is equal to 3 square. What is the answer? 3 3s are very good. 9. 9c square. 3 1s are 3 3s are. So 3 1s are 3 and 3 3s are 9. So we can say that b square is equal to 3c square, or we can write 3c square is equal to what? B square. Same property, LHS is equal to RHS, RHS is equal to LHS. How do we read this? 3 divides b square, then 3 also divides b. 3 also divides b, which means 3 is a common factor. Very nice. Common factor of both. What are the both? A and B. A and B. Where A comma B are co-primes. Where A comma B are what ma? Co-primes. Co-primes means you know well. It's not have a common factor other than 1. So our assumption, the root 3 is rational is wrong. What is the correct? The root 3 is irrational. So this is our 3 similar questions of this exercise. Please copy this one. Okay, we have a fourth question. Show that root 3 plus root 5 is irrational. Okay, this is our next question. Root 3 plus root 5 is irrational. Same we have to follow few steps. So first step we assume, let us assume that root 3 plus root 5 is equal to, if it is a root 3 plus root 5 is irrational, so we have to assume that, let us assume that root 3 plus root 5 is equal to A upon B, where A comma B are what ma? integers. Yes, very good. Where a comma b are integers. And we assume that what root 3 plus root 5 is rational. Rational, which is in the form of p upon q, a upon b, where b is not equal to 0. So after that, we have to take squaring both sides. Squaring both sides. If we are getting the squaring on both sides from here, we have the root 3 plus root 5 is equal to a upon b whole square. Here also we have to take square. So root 3 and root 5 both are what? Root 3 and root 5. Okay, unlike term, we cannot add directly. So in this case we use exponent formula. What is exponent formula? A plus b whole square, a square plus 2ab plus what? B square. Very good. So we use, this is the a value, root 3. This is the b value, root 5. So a square plus 2ab plus b square. A square means who occupy the a place? Root 3 plus 2 into a. What is a value? Root 3. What is b value? Root 5 plus a square plus 2ab plus b square. So a square plus 2ab plus b square. What is b value? Root 5 square is equal to what? A by b square means a square upon b square. So we have to substitute here. After substitution, square root cancel, we have 3 only, plus 2 into multiply this root a into root b, root a into root b means root ab. Okay, so 3 plus 2 root 3 5s are 15 plus root 5 square, what? Very good, 5 is equal to a square upon b square. So we try to add this number, these two numbers we try to add. 5 plus 3 is what? 8 plus 2 root 15 is equal to a square upon b square. So we have to put only in LHS root 5. Remaining terms we have to set in RHS. So we have to set plus 8 into RHS. It will become 2 root 15 is equal to a square upon b square minus 8. Plus 8 comes to right hand side of the equation become minus 8. So similarly, same student, 2 root 15 is equal to, we have to take LCM b square cancel. What we have? A square minus 8 multiplied with b square, 8b square. So these 2 and root 5 both in multiplication. So 2 goes to the denominator. We have root 15 is equal to a square minus 8b square upon what? 2b square. And we observe that this is a RHS. A square minus 8b square upon 2b square is a rational. Is a rational. Yes, because a upon b form. If it is rational, RHS is rational. So root 15 is a rational now. Yes, root 15 is a rational. But what is the contradictory fact? Contradictory fact is root 15 is not a rational. Root 15 is irrational. So our assumption is wrong. What was our assumption? We assume that root 3 plus root 5 is rational. This is wrong. What is correct? The correct statement is root 3 plus root 5 is what? Irrational. Hence proof. Okay. Please copy this. Okay, student, we have another question. Show that root 3 minus root 5. We have taken plus now. We'll try to do the same question with minus sign. Which sign? Minus sign. root 3 minus root 5 is irrational. Okay. So same we have to follow the steps. The first step, let us assume that root 3 minus root 5 is what we assume? Yes, very good, rational. Root 3 minus root 5 is equal to a upon b. Okay, so what is a upon b? A comma b are integers and b not equal to 0. Same previous we have done. So both are unlike term, we cannot add and we cannot subtract. Same we have to take the formula squaring both sides. Root 3 minus root 5 whole square is equal to a upon b whole square. So it is in the form of a minus b whole square. So I will write the formula here, a square plus b square minus 2ab. So what is a value here? Root 3. What is b value here? Root 5. A square, a, what is a? Root 3 square. Plus b, what is b value? Root 5 square. Minus 2 into a. What is a, sir? Root 3. What is b? Root 5 is equal to what? A square upon b square. So square root both cancel, what we have? 3. Square root both cancel, what we have? 5. And 3 plus 5, what ma? 8. Minus 2 root 3 5 of what? 15 is equal to what? A square upon b square. As previous, what we do? We have to send the constant with RHS, means 8. 8 send it in RHS. So what we have? Minus 2 root 5 will be in LHS and a square upon b square it will minus 8. Plus it comes to RHS minus 8. 2 root 15 is equal to a square minus 8 multiply with b square and b square take as a LCM. A square minus 8 into b square. 8 into b square. What is b square? B square is LCM. This minus 2 we have to send in the denominator. What we have? A square minus 8b square upon minus 2b square. So how to remove this minus sign? Just replace negative become positive and positive changes to negative. Then minus sign will be cancelled. Means minus 8b square we have to write positive sign and plus a square we have to write with negative sign. Again we write the step. This is the RHS. 8b square minus a square by 2b square is a rational because it is the form of a upon b now. So root 15 is a rational. If RHS is a rational, then LHS will be a rational. But contradictory fact, root 15 is irrational. If root 15 is irrational, therefore root 3 minus root 5 is also irrational. Hence proof. Okay, you try at home, take some another numbers, take some numbers, root 2 plus root 3, root 2 minus root 3, and take the substitute numbers. 3 root 2 is irrational. Okay, you have to practice. I hope you understood today class. Okay, for more videos, please like, share and subscribe my channel, MA Elisa Maths. Thank you so much.